So with that, what's this guy doing here? So anyway, Pat mentioned about the great future in the Internet of Things, and actually all those things don't yet exist, and we're the things guys at Tyndall in the Internet of Things. Just to put that in perspective, maybe for today, we at the Web Summit, which is the big web developer summit in Dublin, one of the biggest in the world, there were 12,000 people at the summit, and only 50 of them were hardware people. So we are somewhat exotic animals, but hopefully no tagging will go on today. I want to maybe briefly point to two people because we're going to go to lunch very soon, so I'm standing close. Willie and myself are standing between folks and lunch. Kieran Mahuna over here, maybe throw your hand up. So at lunch, if you want to follow up with any Tyndall folk, and Ulden O'Rahilly here on this side, so from our commercial side and also from the research side. So chatting a little bit on sustainable agriculture, food and the environment, or as we call it, SAFE. The purpose of the presentation, or the few slides that I'll give you, I want to give you a brief introduction to Tyndall, because I certainly won't assume that you know who we are. Maybe people in the Cork area would know us evolving out of the National Microelectronics Research Centre, so we have some pedigree going back over 30 years. I'll give you a brief introduction to that, but I want to show you some concrete examples. They'll overlap a little bit with what Frank showed because, of course, we're working in partnership. I'll show you a few concrete examples because we talk a lot about things about the deployment of ICT in food and agriculture in very much in aspirational terms. But as companies like Dairy Master are showing, it's not just aspirational, it's about doing it. And I'm a great believer in just get on with it and learn by doing. So we'll show a few projects that are being realized. Then I'll talk about collaboration because I think collaboration is critical for us for this to happen. And I think there are huge opportunities at the convergence, and that comes from that collaboration. So a few words and a picture, actually. If you walk in our front door, and you're certainly all welcome to come visit us. We're in the Mardyke in Cork City. As you walk in that front door, you'll see this semiconductor fab. We're an organization of a community of some 460 people, scientists, engineers, students. We have about 135 PhD students. And so one of our key outputs is graduating 30 PhD students and putting them out into the research community and industry. We have a turnover a little bit over 30 million euro. Number of things that are very specific there. You can see that we engage with over 200 industrial partners. At the same time, we're very active in publications, so we do take this impact from scientific excellence quite seriously. We are working in very fundamental scientific level. We're highly funded by SFI, and we wouldn't get that money if we weren't working on good science, but it's always needs or market informed. And there's always a view of, well, what's going to happen with this? In fact, we have a tagline in Tyndall we call atoms to systems. So we start at the atomistic level, but we ultimately want to produce a system. And Tyndall makes things. So we do deliver prototypes, and some of the work that we're doing with Frank and Chagas is certainly at the prototype level. Maybe another statistic, along with TSSG, we're probably the two most active research institutes in Ireland in the European Union programs, very successful in Framework 7 and before, and very active in Horizon 2020. And so in some of the projects that will come along now, for us to realize some of these let's say, dreams and inventions and projects, we can go to Europe and get funded for that. The farming community, companies, and research institutes like ourselves. So there are two core parts of the Tyndall. We started, as I said, in 1982 as the National Microelectronics Research Centre, so we have over 200 people doing research in core microelectronics. So maybe the agri-food business does make sense. We've been making chips for a long time. We are also have more than 100 people working in advanced photonics, which is then the manipulation, utilization of light. And that's a very, very powerful technology when you get into diagnosis and sensors. And I think what we're talking about here then is the deployment of sensors in the food and agri environment. So if you look at where we play in Tyndall, we would have been known by many people for our work in microelectronics. That makes you think of the people we work with. Intel is here, and we have a long-standing relationship with Intel, companies like Analog Devices. So people who don't know us well might put us in a box of they work on computation and communications in electronics. But actually, we're very sector-focused, and we've been increasingly looking how can we bring smart technology, sensor technology into other sectors. So specifically, in the last 5 years, we've very much targeted the medtech area. And I think it's an example where you can transfer technology into another area. And so now more than 15% of our activities are putting sensors on medical devices for the Irish medical device technology sector, and they're being used in diagnostic tools, they're being used in surgical tools. So significant gains by translating, let's say, telecom optics into surgical instruments. And indeed, we're the home for the SFI Centre IPIC, and 50% of the activity of that centre is actually using technology that we would have developed in the telecom datacom space, but we're now using it in the biophotonic space or in the medical space. And the ambition that we have now in Tyndall is to look and see how we can collaborate in our, if you will, our 3T partnership with TSSG, Teagasc, and Tyndall, how we can collaborate to move ICT more into the food and agri space. We have a vision for Tyndall, and the vision's the same whatever sector. It's all about how do we train, educate, produce a skilled workforce, and how do we drive disruptive change. Disruptive change, Mark talked about demonstrable impact, and it really comes from making a difference, doing things different. I'll talk about now a couple of examples, and say this will overlap with Frank because it's collaboration. Nanosensors, on-farm diagnostics, and I won't go deep in any technology, but clearly quite a number of opportunities in the nanosensor space. You can see here animal welfare. We've talked about that one before, and you can see on that the number of diseases that we're targeting, the ability to do that field side, real-time, fast diagnostics. The food analysis, so some of the work that's going on there, the environmental work, and water. Water was also mentioned this morning as a big item, and it's an area where sensor technology can play a very, very big part. Nanosensors in its very, very basic form give us something to test, blood, urine, soil sample, and what we then develop are these unique microelectronic-based, nanowire-based sensors. So nano, just from a simplistic view, how small is small? Well, watch your finger and for a second, and it'll grow a nanometer. Of course, you won't see it, but it'll grow that nanometer. So these are very, very fine wires produced in a semiconductor foundry. But by being able to put a tag on those wires, that will make it specific to a disease that's picked up in that blood sample. You'll cross those two wires, you'll change the capacitance, you'll change the voltage, and that will give you a signal that with electronics we can capture, magnify, amplify, and communicate out. Communicate out then into be handled by folks like TSSG to make that then data that goes up into the analysis. You can see the advantage of some of these sensors. What we're really talking about then is taking away the need to take samples and send it to a lab. Putting that lab, if you will, on a little device. If we have, my daughter's a type 1 diabetic, she has a pump and she has a device and she checks her blood several times a day. It's trying to make that type of simplicity for the farmer. If they're buying a calf and they're going to introduce to the herd, a real-time blood sample can tell you whether that animal is going to create a cycle of infection through the herd. And the idea then is not just the speed of it, the simplicity of it, and in action, if you will, in the environment of the farm, but also the ability to then put multiple sensors on a single device, and so test simultaneously for multiple diseases. I flashed these two slides up briefly just because I said the importance of collaboration. Mark talked earlier about the US-Ireland program and some of the other exciting programs he's developing now outside of the collaboration with the National Science Foundation in the United States, talking about the USDA in the United States and equivalent groups in the United Kingdom. We're very active in this program. This is a very exciting program that relates back to the work that we're doing also with Teagasc, connecting us with the Global Food Security Group in Queens in Belfast, to Georgia Tech, to ourselves, funded by Science Foundation Ireland, and then equally funded by all the relevant agencies. So there are opportunities in the funding to really, if you will, triple down on these projects. We're able to combine, in this case, against a single objective, the expertise in Queens, the expertise at Tyndall, and the expertise in Georgia Tech, and all three funding agencies fund the same way. Another example then of work that we are specifically doing Chagas, and the convergence aspect. So we would not typically be a guy that would have thought that we'd be funded by the Department of Agriculture, but it's through the partnership that we have with Chagas. It's through leveraging up. We talked about leveraging cash. This is about leveraging brains and bringing people together to create a much bigger output. Another example, moving from nanosensors, are these biosensors. This is a very, very cool project for us. And I always love projects where the inquisitive people in Tyndall will take a development that we developed for one thing and then move it on to something else. In this case, what we have is an expansion of work that we did in the health space. Mark talked about parallels to the health space. We developed previously a swallowable capsule. What that basically is an electrochemical sensor that, as it moves through your GI system, is doing real-time chemical testing and wirelessly transmitting back to a receiver. This was developed to diagnose the presence and location of intestinal disorders, irritable bowel syndrome. And so you go, well, what does that to do with anything? We've basically now taken the same technology, and just as your internal intestines are a set of pipes, so is a bioreactor, and so is a milk production plant. And so now we're working with the same type of technology, looking for a different actor and letting that flow through milk production and looking for spores, bacteria, looking for purity in the system. Working with NIBRT, we're also doing the same in the biopharma space. So actually taking that, if you will, that internal piping and going into food production. I'll mention this one because we talked about water, and I'll mention it because I just think it's one of the coolest things we've worked on, but it shows you the capabilities and competencies. If you have time later, I think we're all talking about ICT, so everyone's heard of YouTube, so type in BBC shoal, shoal as in shoal of fish. This is a European Union project where we developed electrochemical sensors with partners, created these robotic fish. It's basically to identify bad actors in a harbor. If someone's flushing the bills or polluting the harbor, you don't know until later. So the fact that you have these 3 fish with these super nano sensors swimming around, by triangulation they can detect a polluter at point of pollution and triangulate and send wirelessly the signal to the harbor master to go say, please stop what you're doing and now we're going to fine you. But the idea is that's the technology that's available. So putting this type of sensing stationary in our water system or swimming in our water system. These little fish are smart enough that when their battery gets low, they swim back and dock themselves. So it's a cool video. But to say that the technology is there, it's not just aspirational. And as I say, companies like Ed are grabbing it and using it. It can be deployed. So we are very interested. All of our research work is, let's say, needs-driven, market-informed. And so clearly in Tyndall, what we look to are some of the publications that are coming out. We're working closely with Frank as they develop their new strategic plan. These sign-up sheets that WIT here have, I think, are creating fora where we can actually then build on the challenges that we know. I mean, there's the published challenges, but just as Catherine and others will describe to us, down on the farm, the challenges can be quite different than what we put in our government documents. And so research centers like us, we need to have this active dialogue that days like this create, where we can really understand those needs, and understanding those needs will drive us forward. Collaboration is absolutely critical. So on the upper right of the slide, you can see the MOU that we executed with Chagas last year. I think very, very important. We bring together folks who look at the world completely differently and bring something different to the party, but have a combined and a vision of what we want to do. In the lower right, you can see the esteemed president of WIT and our partnership, our close partnership. Clearly, we bring some 400 plus hardware people together with 120 some software people, and that hardware-software combination is hugely vital. Your phone is not going to work if you only had the hardware, and it's not going to work if you only had the software. And also up here is one of the new centers that was funded by SFI, which is the Connect Center. Very, very powerful center. We're delighted to be play a significant role in that, and Kieran Drain plays a significant role in that. Professor Linda Doyle is the overall director of the center, but there are 3 very critical things. There's the hardware on which it's based, the sensing and picking up that parameter, but then there's that whole layer that sits on top of it that's driven by WIT and TSSG, and then out through into communications. So if you peel away the hardware layer, then in turn this is about layers. And so very, very critical is the work that we're doing in sensors. So realizing low-cost sensors. And the good thing, I think, for ag is we don't work in the lab in some pristine condition. Our customers in the microelectronics industry are in the business of making very large numbers and driving the cost down with scale. And we supply industries like the automotive industry where they're put through their paces in adverse environments. And so we know that the farm is an adverse environment, but the products we make are made for those environments. So coming to closure, the Internet of Things is now the most hyped phrase, etc. I tend to think of the industrial internet. And agriculture is core industry in Ireland. And I think there is a chance for us to differentiate ourselves and be global leaders by deploying the internet in a smart way in Ireland's most important domestic industry, which is our food and agriculture. And I think you can see where we would play with that. So if you haven't been to Tyndall and you've walked by that building and wondered what it was and what the people in there do, that's who we are, and we'd be delighted to have anyone visit us.